started.
Hi guys and gals, and welcome to another segment of Math Maneuvers. I am your mission director, A.S. McKenna.
Let's take a look at your mission objective for today.
It says here that to complete your mission, you need to be able to state correctly the trigonometric ratios of acute angles in a right triangle. Let's go! The right triangle or the right angle triangle. Let's refresh our memory here. What's so special about a right triangle? How would I recognize it? A right triangle has a right angle as one of its three angles. And just in case, we know that it is a right angle because of the box or square symbol used. There's something else that's special about right angle triangles. They are the only triangle to have a special name to one of their three sides. That side is the longest side of the right angle triangle, and it is across from the right angle. This side is called the hypotenuse. Okay, we're going to the drawing board. So we recognize a right triangle or right angle triangle. What about those trigonometric ratios? Well, these ratios express a special relationship among the angles of a right angle triangle and its three sides. There's sine theta, cosine theta, and tangent theta. We usually shorten them to say sine theta, cos theta, tan theta. Again, they are sine theta, cosine theta, and tangent theta, but we usually shorten them to say sine theta, cos theta, and tan theta. I know. You're asking yourself, what is theta, right? I've got you covered. Theta, spelled T-H-E-T-A, theta is the generic name we use to represent angles. So those acute angles that we have as part of our objective, these guys would be theta. Good. So let's get back to those trigonometric ratios. As I said before, these ratios express certain relationships between the angles and sides of a right angle triangle. Sine theta is equal to the opposite over the hypotenuse. Cos theta is equal to the adjacent over the hypotenuse. And tan theta is equal to the opposite over the adjacent. Easy. Opposite, adjacent, hypotenuse. Where did they come from, right? Well, we already know what the hypotenuse is and where it is located. Remember, the longest side is the hypotenuse and it is located across from the right angle. The opposite and the adjacent sides depend on the location of our theta, our acute angle. In this case, our acute angle is to the bottom. The opposite side will be the side across from, facing, well, opposite to our theta. The adjacent side would be the side that is next to touching, or well, adjacent to our theta. Notice that the hypotenuse and the adjacent form our theta. They form our acute angle. Now let's look at our theta in another location. Notice that the hypotenuse remains in the same spot. Let's look to see where our opposite and our adjacent would be in this situation. Again, our opposite would be the side that is across from, facing, or opposite to our theta, and the adjacent would be the side that is next to, touching, or adjacent to our theta. Spot check time. See if you can identify the 3 sides to each triangle. We'll be doing 4. Identify where the hypotenuse, the opposite, and the adjacent are in relation to our theta in each case. You'll have 15 seconds for each. Remember, if you need more time, press that pause button. Good. In this case, our theta is to the bottom. Our hypotenuse is easily located. It is across from the right angle triangle. And our adjacent will be the line touching our theta. The opposite will be the line across from. On to question 2. Remember, 15 seconds, and remember, take note of where our theta is in question number 2. Okay, in this case, our theta is to the top. Remember, our hypotenuse is easy. It's always the longest side, always the side across from the right angle. In relation to our theta, we would find that the line to the bottom is opposite and the line to the side is adjacent. On to question number 3. He's all the way up there. In triangle number 3, we look for the hypotenuse situated across from the right angle. Then we look at our theta to find our opposite and our adjacent. Remember, the opposite would be the side across from our theta, our acute angle, and the adjacent would be the line that is next to and touching our acute angle. On to number 4. Remember, pay attention to that theta. Great. Once again, let's take a look at our theta. Find our hypotenuse across from the right angle, and then using that theta, we can locate the opposite across from the theta and the adjacent, which is next to our theta. Excellent. Nice. We can now correctly identify the hypotenuse, the adjacent, and the opposite of our theta in our right angle triangles. Now let's get back to those trigonometric ratios. Remember, Sine theta is equal to the opposite over the hypotenuse. Cos theta is equal to the adjacent over the hypotenuse. And tan theta is equal to the opposite over the adjacent. Makes more sense now, right? We have another secret weapon. To help us remember these ratios, we have a special mnemonic device. To make this mnemonic device, we take the S from sine, the O from the opposite in our sine theta ratio, the H from the hypotenuse in our sine theta ratio to form SO. Next, we take the C from cos, the A from the adjacent in the cos theta ratio, the H from the hypotenuse in the cos theta ratio to form Ka. Finally, we take the T from tan, the O from the opposite in our tan theta ratio, and the A from the adjacent in our tan theta ratio to form TOA. Put them together and you get SOHCAHTOA. Say it 3 times. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Now to complete our mission, let's correctly state the trigonometric ratios for a few right angle triangles. We'll be doing 3. I'll work with you for the first one. For the right angle triangle or the right triangle, state sine theta. Keep in mind our SOHCAHTOA. Our SOHCAHTOA lets us know that our sine theta ratio is the opposite over the hypotenuse, O over H for our SO. Using the location of our theta in this triangle, we can see that our opposite is 3 and our hypotenuse is 5. So our sine theta ratio is 3/5. Next, we move on to cos theta. Again, SOHCAHTOA, keeping in mind that Ka, it lets us know that our ratio for cos theta is the adjacent over the hypotenuse. Using the location of our theta in this triangle, we can see that the adjacent is 4 and our hypotenuse is 5. So our cos theta ratio would be 4/5 or 4/5. Finally, we look at tan theta. SOHCAHTOA. We are looking at our TOA in this case. Using our TOA, we can form the ratio opposite over adjacent, O over A. Looking at the location of our theta, we can see that opposite our theta is 3 and adjacent to our theta is 4. So our tan theta ratio would be 3/4 or 3/4. Now it's your turn. For the right angle triangle, state sine theta, cos theta, and tan theta. Keep in mind that SOHCAHTOA when you're doing your questions. Press pause while you are working out your questions and press play to resume when you are finished. Good. So using our SO from SOHCAHTOA, we know that our ratio is opposite over hypotenuse, O over H. Using the location of our theta in this triangle, we can see that the opposite to our theta is 4 and our hypotenuse has a value of 5. So our sine theta is 4/5. We move on next to the cos theta, which is adjacent over hypotenuse, A over H, using that Ka. From our theta, we can see that the adjacent is 3 and the hypotenuse is 5. So our cos theta ratio is 3 over 5 or 3/5. Tan theta, TOA, O over A, opposite over adjacent. Using the location of our theta, we see that our opposite is 4 and our adjacent is 3. Well done. Let's move on to our final question. For our final question, once again, for the right angle triangle, state sine theta, cos theta, and tan theta. Keep in mind that SOHCAHTOA, press pause while you are doing your work and then press play when you are ready to see the answer. Good. So sine theta, that's so, is O over H, opposite over hypotenuse. Using the location of our theta in this triangle, we can see that our opposite is 12 and our hypotenuse is 13. So our sine theta is 12 over 13. Cos theta, A over H, adjacent over hypotenuse. Using the location of our theta, we can see that our adjacent has a value of 5 and our hypotenuse is 13. So our cos theta ratio is 5 over 13 or 5/13. And finally, tan, TOA, O over A, opposite over adjacent. Our tan theta, using the location of theta in this triangle, would be 12 over 5, 12 being our opposite and 5 being our adjacent. Excellent work. Now you may be asking yourselves, why is this important? What's the big deal with SOHCAHTOA? Well, because of each relationship, we can form equations, and these equations allow us to work out the magnitude of angles when we know the length of sides, and they allow us to work out the length of sides when we know the magnitude of angles. And this in turn is important for many industries. For the gaming industry, for Amelia, who would like to know how to code her character to turn to go up a slope. For the construction and architecture industry, for James, who needs to know the height of a building before he can design plans for an addition to it. And in navigation, for Vishnu, who may not have his Google Maps, but needs to use his SOHCAHTOA to find out how far away he is from land. During our next mission, we will put SOHCAHTOA to work to do just that, solve problems. For now, our mission objective was to correctly state the trigonometric ratios of acute angles in a right triangle, and we did just that. So I say mission complete.